Welcome back. This is ASIC, FPGA, and DDR rail power design through PMBus power supplies. In this segment, you will learn what PMBus Telemetry does and what types of power solutions with PMBus TI has to offer. The benefits of PMBus monitoring are several. With PMBus, you can monitor current, voltage, and temperature. The Fusion Digital Power Designer software has several menus, one of which is the monitor screen that you see here. On that screen, you can monitor the output voltage, output current, temperature, input voltage, and input current, as well as, with some of our multi-phase controllers, input power and output power as well. Next, we'll do an active demo. So this is the TI Design PMP10896 demo board powered up with a Fusion GUI showing how the parameters that we want to measure are monitored via the Fusion GUI. So here what you see on the left is the UCD90240 monitoring these three analog voltage regulators here, the TPS40428 monitoring its two outputs, because it's a dual buck controller, dual phase as well, and then the two individual 30 amp PMBus converters, TPS544C25, on the last two monitors on the right. With PMBus, as we mentioned, you can do margining as well as change the output voltage, and that will immediately be reflected at the output with the Vout command. So let's try it. We're going to change the output voltage here from 1.1 volts to maybe something lower, like 0.9. You can see how the output voltage now changed, and you will also see that the warning over voltage and under voltage warning and fault levels are tracking the output voltage change accordingly. We can choose more parameters to be shown. So, for example, here we can select also output current as well as output power. Now, right now this rail is not loaded, so you see 0 amps because we don't have a load on it, but if it was, you would also be seeing that line being anywhere from from 0 to 30 amps, and you would also see the corresponding output power, which is calculated by the GUI, which is a multiplication product of V out times I out. Same thing with the three rails, three analog voltage regulator rails that are monitored by the UCD90240 PMBus Manager. We can also show output current and the calculated output power. All of those are now reflected on the left on the UCD90240 monitor. This is a full Ethernet switch PMBus demo where the UCD9240 manages the analog voltage regulators and also implements monitoring of the voltage, current, and temperature. And this demo also includes the PMBus regulators, TPS544C25 30 amp with integrated FETs, as well as the TPS40428 dual output or dual phase PMBus buck controller. At any point you want to change, you want to disable the regulators, you go to the central control line and you turn them low, and that will disable all the regulators on the board. This is the PMP 108096 TI Design board close-up. On this board, as we mentioned, you will see we have the 12 volt input coming in, the 12 volt PMBus hot swap controller that provides not just protection for the rest of the card, but also PMBus monitoring of the input voltage and current, the four analog voltage regulators that are sequenced and monitored through the UCD90240 24L PMBus sequencer with black box recording capability, and then the three PMBus voltage regulators, two 30 amp PMBus converters, and one dual output or dual phase PMBus buck controller. Also in this design, you will see that we're employing, to minimize XY area on the PCB, inductor on top designs. These inductors have longer legs and stand on top of the ICs, allowing enough air gap to have excellent thermal performance while minimizing the X and Y area on the board as they stand on top of the IC and really reduce that PCB area. The complete PMP10896 TI design is fully downloadable from the TI Designs webpage with schematics, bill of materials, and layout files ready to be used. This is TI's PMBus power ecosystem. TI offers a wide range of power supply ICs with PMBus from 48-volt input to point-of-load DC to DC conversion. The parts that you see in blue are all PMBus compliant. For 48-volt input, we have the LM5064 and 5066i hot swap controllers with PMBus. For the isolated DC to DC converter, we have the UCD3138 that can be used to implement various isolated DC to DC converter topologies such as forward, half bridge, or full bridge. And we also have the PMBus point-of-load DC to DC controllers and converters on the right. There are several options from single phase to multi-phase, from single to dual output, as well as high current PMBus buck converters ranging from 12 amps all the way up to 40 amp devices. This is an XY chart that shows all the PMBus TI designs TI has to offer on our TI Designs webpage. This is an XY chart that shows that on the x-axis, if you have any input voltage from 3 to 28 volts, we have solutions with PMBus that range from 4 amps that you see on the y-axis, which is the output current, all the way to 200 to 20 amps. These are the controllers or buck converters and the corresponding PMP TI designs that you see there. This is an example of a PMBus TI design. This is TI Design PMP10896, and it's a complete Ethernet switch PMBus point-of-load solution that's available for you to download. This is a power system that has 8 voltage regulators, a UCD90240 24-rail PMBus sequencer that includes black box recording capability, and a 12-volt input PMBus hot swap controller. This TI design is a 300-watt system power solution. It uses PMBus communication to configure all the PMBus ICs from the hot swap to the Swift buck converters to the multi-phase PWM controllers. And it enables very high power density power conversion utilizing inductor on top designs to minimize XY area. Voltage margining through PWM, PMBus, and AVS bus is also offered. The UCD90240 GPIs allow for event-based power supply control, and all these PMBus ICs come with Fusion, Digital Power Designer, and manufacturing GUI support. For more resources, please visit the links below. Thank you for watching.